All right, so number one, on the quiz, everybody, we're making some mistakes. This is f and g. And remember, we know that the derivative of fg is f prime g plus g prime f. Guys, it has to be two terms. Two terms are separated by a plus sign, not a times sign. So go try these two problems, and we'll go over them real fast in about 50 seconds. All right, so everybody, I see f as x, I see g as secant 3x. So the derivative of x, f prime, right? So y prime equals, if I call this stuff y, 1 times secant 3x. That is f prime g, plus, because it's two terms. F is just x, right? So I'll put that in right away. And now g prime, derivative of secant 3x. You don't know secant 3x, but you know secant x is secant tangent. So it's secant 3x tangent 3x. And then you just do the chain rule. And the derivative of 3x is simply 3. So I'll put the 3 in front. And that's the derivative, all right, of that function. On the next problem, limit as x approaches infinity. This is a simple rule, and you guys should be able to picture it. If you look at the highest power on top and bottom of this rational function, you get 4 over x, right? We knew from way back when, as you go out to x, and if it's 1 over x, right, it goes to 0, because we have a rule. Our rule is this. Any x to the n power where n 1 or greater goes to 0. This always equals 0. This is our rule. We get this situation here, so it is equal to 0. Pretty fast, pretty straightforward. I do have one more warm-up problem I thought we'd do together. I'd do for you today. Cole, this is just for you, baby. Cole's birthday cake is increasing in area because so many people like him. Now just bear with me, okay? I know sometimes we don't do real-world problems in calculus, okay? It is increasing at 12 square inches per hour. If the width is half the length and is increasing at 1/2 inch per hour, how fast is the length changing when the area of his birthday cake is 200 square inches? Cole, you thought there would not be real things. Happy 18th birthday. We're gonna make you a cake.
Is this gonna be a square cake or a round cake? Because it says length, and I'm confused if that could even happen in a circle.
It's gonna have to be rectangular. Yep.
Okay, just make sure.
Yep, it's gonna have to be rectangular because I said length and width.
Oh, I didn't see that.
Yep. So in the problem it says area, length, and width. And I don't know the size of thy birthday cake, but we know that more and more people want to come hang out with Cole. And it says the width is equivalent to 1/2 the length. So here's where I think I am right away. I don't even think I want to deal with the width. I'm just going to drop it right away. But it says, how fast is the length changing when the cake is 200 square inches? Okay, so I give dA dt right up here, right? It's increasing at 12 square inches per hour. Cake's getting bigger. And I asked for dL dt when the area was 200. That's our unknown. And the only other thing we know is that the length is increasing at, oh wait a minute, I gave the length. No, I gave the width. I gave the width is increasing at 1/2 inch of an hour, but I suppose you didn't need that, did you? I tried to make this up on the fly. I don't need that, do I? So let's pretend I didn't put it in there. Yep, we'll just get rid of it. All right, so here we are. We have a relationship, right? Do you guys agree? On the cake, we have area equals length times width, but if I replace the width with 1/2 L, I think what I can write then is area equals 1/2 L squared. You guys agree for the area of the cake? And everybody, you notice I haven't stuck in 200, and I haven't bothered figuring out L yet. And here's one thing. You notice I multiplied right away. Everybody, one thing I noticed on one of the quizzes, you cannot take the derivative of 1/2 LL and write 1/2 L. This would be a product rule again if you wanted a derivative of this. But you should simplify your equations the entire way, okay? On the gravel pile, we do not take the derivative of h and h squared separately. We do h cubed. Oh, area equals length times width, and width is 1/2 L. That's all right. So I plugged that in. 1/2 L times L is 1/2 L squared. So before I do any number stuff, since everything is changing, I would take the derivative of this. dA dt is derivative of a. Derivative of 1/2 L squared is 2 times 1/2 is 1. So how about L dL dt? All right. I want to find dL dt. You notice the area is insignificant. I don't have the A, but dA dt I know is 12 inches, right? I want to find this. This is my unknown. What do I have to also know? This time I have to know L. But we have this neat formula right here where I said, hey, the area of a cake, and I hope I did this right. I said it was 200 square inches, right? Oh, I did. I did this right. It's going to be an integer. I multiply both sides by 2, right? Everybody agree that the length of this cake is now going to be 20 inches? All right, so now I know L. So now it's just plug and chug time. It's 12 square inches per hour equals 20 inches dL dt. Divide both sides by 20 inches, and I think what you get is 12/20ths is 6/10. How about 0.6 inches per hour would be the change in length of the cake. So it's increasing by 0.6 inches per hour. All right? Not very fast, but that's life in the city. Everybody, again, a pretty straightforward related rate problem. A little bad math, a little bad English on my part. I shouldn't have included this part. And I think, but if you take that part out, this problem goes pretty straightforward. And it's increasing at a rate of a little over 1/2 inch per hour.
Very large. Would you please dial extension 221? Very large. Would you please dial extension 221?
So what would happen if you're eating this at the same time it's growing? I feel like it's...
We're making one common error, and I'm going to give up implicit differentiation example. Yeah, and we have two positions, and I'll do this one. Everybody, we should see two things right away. We see product rules in the first two terms, guys. And what's the derivative of 7? 0. Albany, listen carefully to what I say. The derivative of 7 is 0, and I don't care if that's dx or dy. Derivative of a constant is always 0. You can't leave it. It gives you too many terms, too. Now, we also know that we have to start practicing because we do not want to write, if I call this f, we do not want to write 3x squared dx. Every time we do a product rule, we want to, if it's derivative with respect to x, we don't write anything. And if it's a derivative with respect to y, we write y prime. So I will do the x derivative first in this first term, which is 3x squared times 2, which is 6x squared y squared. We took the derivative with respect to x, so I don't write anything. Plus. Now I'm going to take the derivative of y, which is y squared. Derivative of y squared is 2y. And I'm going to, all right, thank you. And I'm going to do the next term, I'm going to do it in black. Now, everybody, the negative sign is going to distribute to both terms, so I'm going to write in the two negatives right away. Right? Now I'm going to do the product rule. I'm going to do it with respect to x. Derivative of x squared is 2x. Times 3 is 6xy. Don't write anything because it's derivative with respect to x. Now I take the derivative with respect to y. Derivative of y is just 1. But I need the y prime. Everybody, calculus is over. Algebra 2 has started. Algebra 2. I will send... You guys always whine about it.
No, I didn't.
I will send those to the other side. And what I have left on the left side here is x squared, y squared. The stuff... Here's what I want you guys to catch. Every derivative with respect to x ends up on one side. And every derivative with respect to y, in this case, ends up on the other. And opposite signs, we got a little algebra thing going on, right? My favorite trick from Algebra 2 is anytime I want, I can do this. Now I can see it's y prime times the stuff. Bumped it with my sleeve. And then everybody, all we gotta do is divide. Don't get cute. There's nothing to simplify. All right. 3, 4, 6, and 6, they don't share a common factor. X squared, y squared, xy, x squared. It looks like I can factor an x, everybody. So that's what I'll do. Did I have like terms again?
You
No.
have to factor that in.
You bet you better factor that x. We have to.
Don't be cute.
I agree. Don't be cute, but we factor our x's. And everybody, I suppose I could write it out here so we make sure we understand how I did that so fast. Right? And then x divided by x is 1. Alright, so these are some warm-ups today.